Hey guys, welcome back. So in the last video we learnt how to dequeue an element from a circular queue. Hope you have understood that concept. Now in this video, let's see some more operations that can be performed on a circular queue. So one of the operation is a peek operation. So as we already know, a peek operation is same as a dequeue operation. The only difference is we don't delete that element. We simply see that element. So let's say if this is our queue, then if we do a peek operation and this is our beginning or start of the queue, then we simply return the value in this cell and we don't touch it. So the same thing we are doing here. If queue is not empty, then we are printing ARR start, that is the beginning of the queue. Else we print the queue is empty. So the peek operation is as simple as that. Now if we see the time and space complexity of this algorithm, as you would have guessed, both of them are order of 1. Now moving on to the next operation, it is isEmpty operation. So in isEmpty operation, we basically check if the queue is empty or not. So to check that, the answer is simple. We just have to see if top of queue is equal to -1. Then we can safely say the queue is empty. Else it is not empty. Now if you see the time and space complexity, again both of them are order of 1 because we are not using any extra space or time for doing this operation. Now moving on to the next operation, which is isFull operation. In isFull operation, we check if the queue is full or not. So in this operation, we can have 3 cases. Let's discuss all of them one by one. So the first case is, if we have already completed a circle, then we can say that the queue is full. What that means is, if our queue looks like this, that is, starting is over here 10, it goes on 20, 30, 40, 50, 60 and 70 is the top of the queue. In this case, top of queue, which is 1 here plus 1, 2 is equal to start, which is also 2. So we can say that this queue is full and we can't insert any more values. The other case can be the trivial case which we saw in the linear queue as well. That is, if start is at 0 and top of queue plus 1 is equals to size. So if our queue looks like this, the start is pointing to the first cell in the array and top is pointing to the last cell in the array, then we can clearly see here that this queue is full. So that is case number 2. And the last thing which is possible is when the queue is not full, which can be any other case apart from these 2 cases. So let's say if start is pointing to the first cell and top is pointing to this cell, then we can return false, saying that the queue is right now not full because we have one cell empty over here. Similarly, in this case, start is over here, top is over here, and we have one cell over here remaining. So in this case also, the condition will come to this else block and will return a false, saying that the queue is not full. Fine. So I hope you have understood isFull operation. Now let's quickly see the time and space complexity of this algorithm. So as you would have guessed, all of these statements are constant time. So total all of this will be order of 1 time. Space complexity is also order of 1 because we are not using any extra space for any of this statement. Now let's move on to the last operation of a circular queue, that is deleting a circular queue. So deleting a circular queue is very simple. We just have to make the array as null. The array stores the entire queue. If it is made null, the entire queue will also collapse. And if we see the time and space complexity of this algorithm, it is order of 1 because we are not using any extra space and this one statement will take constant time. Now before concluding the circular queue chapter, let's quickly see all of these operations in a tabular format and how much time and space complexity was involved in each of those operations. So as we can see here, all of the operations in circular queue, if implemented via array, will take order of 1 time. Similarly, space will also take order of 1. The only case difference here is the creation of a queue, which will of course take order of n space because we will create a blank array of size n. So it will take order of n space. Fine. So with that we come to end of circular queue chapter. The array implementation is available in Java language in the resource section. In case if you need it, please have a look there. Thanks for your time. See you in the next video.